Hi guys. Today we're going to be doing the practice problems that go along with lesson 2-3, rational and irrational real number families. This is on page 99 of your workbook. These first 8 problems, they want you to just go through and tell if they're rational or irrational. So what you're basically looking for here is square root signs. If they have square root signs, is the number under the square root a perfect square or is it not? So for number 1, a negative square root of 10. Well, 10 is not a perfect square, so that is an irrational number. The negative has no meaning here. You can be rational and be negative, but because 10 is not a perfect square, that's irrational. All right. Number 2, this is rational. All right. Anything that can be written as a fraction is rational. Point 3, repeating. Rational numbers include repeating decimals. So this one's rational. Repeating decimals can be written as fractions. This is actually 3/9, or 1/3. It's a reduced version of it. Square root of 81. Is 81 a perfect square? Yes, it is. The square root of 81 is 9, and that's rational. I hope you're paying attention because I'm going to have to use these same problems on the McGraw-Hill practice assignment. Number 5, 0 is rational. It's a whole number, it's rational. Number 6, the square root of 2. Is the square root of 2, is 2 a perfect square? It is not a perfect square. And in order for you to be a rational number, the top and bottom of the fraction have to be integers. Square root of 2 is not an integer, it's an irrational number. The square root of 2 makes the entire number irrational. If there is a square root of anything that's not a perfect square, it makes the whole number irrational. 7 is not a perfect square, it's irrational. IRAT for short. And the square root of 2 over the square root of 2. Now this is an interesting one, because what happens if you have one number over itself? Isn't that equal to 1? So because we have the square root of 2 over the square root of 2, this is actually equal to 1, which surprisingly enough makes this a rational number. This would be the only time when you could have an irrational number as if it's over itself, okay? That would make it equal to 1. All right. Select all the sets of numbers to which each real number belongs. The cube root of 343 is equal to 7. You have to think about what it's equal to. If the number under here was not a perfect cube, this would be a totally different story. But because this is equal to 7, it makes this rational, not irrational. You can only be one or the other. It is an integer. 7 is an integer. 7 is a whole number. And 7 is a natural number. Okay, it belongs to all those families. 7 over the square root of 2. Because this is not a perfect square, it renders the entire fraction irrational. And once you're irrational, that's all you can be, all right? We don't let irrational numbers into any of the rational number groups. Negative 7 over 1 is equal to negative 7, all right? Well, that is a rational number, first of all, not irrational. Remember, I said you can only be rational or irrational. You can't be both. Negative 7 is also an integer. It is not a whole number. Whole numbers don't include any negatives, nor do the natural numbers. So it's just rational and an integer. Determine whether each statement is true or false. If the statement is true, explain your reasoning. If the statement is false, provide a counterexample. A number cannot be irrational and an integer. Okay? This is true. No irrational number can be an integer. So this is true, and I need to explain my reasoning. Well, irrational numbers are decimals that do not terminate and do not repeat. Decimals do not belong to the integer club. Therefore, irrational numbers can never be integers. Can't even talk. All integers are rational. This is true, because in order to be an integer, you need to be a whole number and its opposite. So all the positive and negative whole numbers, and they can all be written as fractions. So that's true. Select the numbers that are part of the set of rational numbers. Okay, is this rational? Check out, we've got a square root sign, but 9 is a perfect square. So this is actually equal to negative 11 over 3, which is rational. Okay. Now this, too, is not a perfect square. So that renders the entire fraction irrational. So we're not checking that one. This is not rational because although 16 is a perfect square, negative 16, remember I told you that that's impossible, that is an imaginary number, and imaginary numbers aren't even real numbers. So definitely not rational. Oh boy, cube root of 4,090. Oh, I'm going to need a calculator for that. Oh, gotta do the cube root. Didn't see that coming. All right, so 3-second cube root 4096. Let's see. 16. So this one is equal to negative 16 over the square root of 16. Well, is 16 a perfect square? Heck yes, it is. So now we have negative 16 over 4, which is equal to negative 4. That's rational. Okay. The cube root of 4. Okay, 4 is not a perfect cube, so the cube root of 4 is not rational. It's going to be a decimal that never ends and never repeats. If you don't believe me, you can put it in your calculator. Do 3-second caret and put 4 in there. When you do that, you're going to see that it fills the calculator screen here. And so therefore it's irrational. So we're not going to mark that one. 0.3 repeating is equal to 1/3, which is rational. Yep. Pretty cool. Okay, explain how you could use a calculator to determine if the square root of 8 expressed as a decimal ever terminates. Pretty much all you can do is put the square root of 8 in a calculator. It'll fill the screen and it doesn't appear to end, so you just have to go with that. Plus, you know from experience that 8 is not a perfect square. Therefore, the square root of 8 is irrational. Determine whether each statement is true or false. If the statement is false, give a counter example or explain your reasoning. The product of a non-zero rational number and an irrational number is rational. No. If you multiply anything times an irrational number, you get an irrational number. You just get a bigger irrational number. Expressing the square root of 2 as the ratio of square root of 2 over 1 means that square root of 2 is a rational number. We've already talked about problems like this. If there is a square root of a non-perfect square anywhere in the fraction, it makes the number irrational. So that is false. The only exception would be in the case when you have like square root of 2 over the square root of 2, because that reduces to 1. But unless there's a matching one for it, it's irrational. The product of two irrational numbers is irrational. This is true. Whenever you multiply anything times an irrational number, it becomes irrational. Even an irrational times an irrational, you still get irrational. And that's our last example for today. So, what should be our secret word? I'll tell you what our secret word is going to be. Today, the secret word is rat, because it's in rational and irrational. So, rat is your secret word. Feel free to watch this video multiple times if you really just think it was that good and you had a great time. And make sure you hop on over to McGraw-Hill and complete that assignment and use these problems as notes, because you're likely to see several of them over there again. Have a great one.